Okay, I'm gonna start with a question actually. How many people have used, or put up your hand if you've used Elasticsearch at all? Yay! Put up your hand if you're a rabid fan and don't want to hear about alternatives. I've used Elasticsearch quite a bit over the years. If you've ever seen me talk about the Nodezoo demonstration microservice system, that uses Elasticsearch. I built the search system and in fact the entire system for the Sunday Business Post about 6 or 7 years ago. Used Elasticsearch for that, and the problem was the search results were always pretty poor quality, and you were sort of reduced to messing about with boost factors on specific fields, that sort of thing, to try and improve the quality. But it was kind of voodoo, it was kind of a black art. And about a month ago, Yahoo open sourced their internal search engine. And I saw it as like a link on Hacker News. Obviously, I was working extremely hard reading Hacker News, and I decided I'd download it and start playing around with it. So they called it Vespa. Vespa.ai is the link. And first of all, I thought, well, just having a quick look at the architecture, it looked like a really interesting microservices system, which kind of encouraged me to think about, well, I'll investigate it, see how it works, and then talk about it at the meetup. But actually, after investigating it, I decided to go in a totally different direction. As a microservices platform, Vespa.ai is actually pretty cool. It's a Java system, and it's designed so that all of the microservices, you run all of your microservices in one machine, and then you run lots of machines. That's the basic architecture. It uses Zookeeper for service discovery. So for one machine or one microservice to find another, you have a service discovery mechanism. It's fairly straightforward. Although it's a search engine, you can deploy pretty much any Java application. It's a Java application server, essentially. So if you're looking for a way to deploy scalable Java microservices, this is actually a pretty good platform. It is a platform that has come from a traditional Java background, so you build application packages, it uses OSGI modules, all that sort of stuff, and it's pretty straightforward to use. And in fact, because it is so straightforward, because it is so traditional in terms of Java applications, it's actually not that interesting as a microservices platform. The cool thing about it is it's really robust. So it's an alternative to things like Dropwizard and that sort of stuff. It gives you really easy scaling up and down, all that sort of thing. And that was one slide. I was kind of done. But I started playing around with it from a search engine perspective. And the really interesting thing about Vespa.ai is that it uses machine learning to improve search quality considerably. So if you're building a system or an application that needs a really good search engine, I would seriously encourage you to take a look at Vespa. And I'll try and explain why it's really good and why it's much better than Elasticsearch. But first, just a little bit of background. So it was open source literally a month ago. It's up on GitHub. If you go to the GitHub repo, you'll see that it's an absolutely enormous system. There's 50 subfolders, hundreds of files. It would be really hard to understand the system itself. But luckily, the guys at Yahoo that open sourced it have packaged it together into Docker containers. They put together some really, really awesome documentation that explains how to use it. So it's pretty much usable out of the box. You don't have to understand much about the system to get it up and running. And the key thing about it is that it's designed for really low latency user interactions. So not just to give you search results, but to give you search results that are specific and good for that user. And that's why it's so cool. It uses machine learning to do that. It's actually not used for Yahoo's main search. Yahoo did some sort of a commercial deal with Microsoft, so they have to use Bing for that. But but it is used for Flickr search and Yahoo Finance and a whole bunch of other things. So it's proven in production. It's actually, the system is actually about 17 years old. And it came from All the Web, which was acquired by Overture, which Yahoo then acquired. And the system has been refactored multiple times, so it's really, really robust. It works really, really nicely. But now I'm talking about search engines. So if you take a system architect perspective, you have to ask, well, how does this compare to all of the alternatives? It seems to me there's about 5 basic choices. We have Elasticsearch, obviously. Has anyone heard of Algolia? So they're this really, really cool French company that does kind of search in a box. And you just plug in their API, you get really high quality search. Finished, job done. We can all go home. We don't need to look at Vespa at all. But of course, you have to pay. Solr has always been the alternative to Elasticsearch. And of course, you can just use the free text search option of your database. I'm not going to give you a feature matrix of all these. I think we can kind of boil it down to the essential primary feature of each one. The interesting thing about Elasticsearch, it started off as a search engine, but the emphasis has moved to analytics. That's because Elastic, the company that looks after Elasticsearch, obviously needs to make money, and there's way more money in analytics than there is in basic search these days. So Elasticsearch is fantastic for searching your log files, not so great for building a user-focused search. The search results aren't as good, and there hasn't been as much improvement over the years. Algolia is this cloud-based platform, gives you great results, but you have to pay for it, which may or may not suit. Also, obviously not on-premise. Solr is a good alternative to Elasticsearch, but it's highly Java-focused, whereas Elasticsearch lets you integrate with Python and all that sort of stuff. And obviously, if you don't want to bother with too much extra configuration installation, just use the free text search capabilities of your database if you want bad results, because it works, but it doesn't work that well. And then you have Vespa, which uses machine learning to give you good results. So this is kind of the choice matrix. So to put this into context, so you can kind of understand the problems it solves and how you go about using it, I'm going to give you a concrete use case, which is the new startup that I'm setting up. So Betsitaba is my new startup, which I set up about a month ago. And it's a social network for the conferences and events industry. Why is that necessary? Well, if you think about all of the stakeholders in the conferences and events industry, you have a whole bunch of different people that need to talk to each other. So speakers, conference organizers, attendees, like your good selves, people who sponsor, the venues. All of these different people have tons and tons of workflows that they need to make happen. And if you look at the industry, at the moment, most of these are done by email and spreadsheets. It's all really, really efficient. So part of what I'm doing is trying to make this super efficient by building a social network that has workflows that makes it all happen nicely. But one of the key problems is discovery. How do these people find each other? Every time you have an event, you have to find speakers. Attendees have to find events to go to. They have to choose events based on certain criteria. If you're trying to host an event, you have to find a venue. You have to find audiovisual people. It's actually really hard if you're running a lot of events to find all of the service providers that you need. Even as a speaker, you know, I like to speak at 1 or 2 conferences a month, but finding the right conferences, interacting with them, sending in proposals, all that sort of stuff, there's a ton of work involved. So if you can make all that easier, especially finding other people in the industry, that would solve a really big problem. And just to give you an example of the types of search problem that I'd like to solve, here are some sample queries. Right, so let's say I'm trying to find speakers for an internal seminar on microservices in Birmingham. And these are all real examples of stuff that I have had to do in the past. Right, so where do you find people who are willing to go to Birmingham who know about microservices at 2 weeks' notice? Or let's say I want to speak at conferences in the US. I I want to, do that 2 or 3 months of the year. How do I find conferences in Austin that are on Node.js early next year? If I'm running a conference in New York, I found this really cool building that I can have a really cool conference, really cool tech conference in, but I need to find AV people in Brooklyn. Do I just look them up on Google? How do I know they're any good? How do I know they're reliable? All of these are real things that I've had to solve and have solved with manual labor. So if you can make queries like this work, you have something valuable and useful. Elasticsearch can't solve these types of problems because free text search, even good free text search, doesn't understand the structure of the question. So all of these current offerings suck when it comes to this problem. They suck because the free text quality results are low. People try to get around that. So if you go to meetup.com or Eventbrite or various conference directories, you have to type in the location where you are. You have to search, you have to select categories, you have to search date ranges. Instead of just, the way Google works, you just type in the query and you get results straight away. That's all you should have to do. And there's no personalization. So when I search for a conference, the system should know that I care much more about microservices than I care about medical supplies. It should know me. So then you can ask the question, well, how do you improve search quality? And this is why Vespa is really cool, because it solves this problem. I'm going to try and explain how. So if you think about search results being good, you can turn that into 2 specific measurements. One of them is something called precision, which is the number of results that are relevant. So when you get a list of 20 results, how many of those results are things that you were looking for? How many of them aren't? It's a percentage. The ones that aren't relevant, if I was looking for microservices conferences and it brings up .NET conferences, the .NET conferences are false positives. I was not looking for them. So 1 minus the false positives. And if you think about it graphically, all of the rectangle is my search results. The green is the stuff I wanted, and the red is the stuff I didn't want. Green is the relevant results, and red is not. So I'm only 33% precise in this result set, which is not great. The other metric is something called recall, which is kind of the logical inverse, I guess. It's the number of relevant items in the results. So if you think about it, I want to get all of the microservices conferences. I don't want to miss out on any of them. If I miss some of them, that's bad. I'm not getting full recall. So in that case, it's 1 minus the false negatives. The false negative is when I miss a microservice conference. So if I look at my full data set, and the bigger rectangle represents the full data set, if I only return half of all possible green, then my recall is 50%. So these 2 metrics let you measure the quality of search results. Instead of just saying, they sort of feel good, you can say, I need high precision and I need high recall. So what's wrong with Elasticsearch? It gives you good recall, but bad precision. It tries to give you everything that's green, but in doing so, drags along a whole bunch of red stuff as well. So although I may list all of the microservices conferences, I've also got all the .NET conferences and all the Java conferences mixed in there. So I can't get to the stuff I'm looking for. It's all in a list of 500 results, as opposed to being on the first page. The problem is caused by the algorithm, the ranking algorithm, how you decide which results come first. With Elasticsearch and most of these search tools, it uses word frequency. So if a word occurs more often in a document, the document goes higher up the result list, which is a good heuristic, but it doesn't capture meaning and it doesn't capture the structure of the data. Vespa is cool because it balances recall and precision. So you get more of the green and less of the red. And the way you do that is the ranking the order of results is driven by machine learning. So how does that work? Well, this is where we go into a little bit of maths, but I've tried to make it understandable. So let's see if it works. So if you remember from studying maths in school, a scalar is something that has a single value, and a vector is something that has two values, right? Magnitude and direction. And a tensor, which is the cool buzzword in machine learning, is just a generalization of that idea. It's got n values. All fields have wonderful buzzwords. Tensor is the wonderful buzzword that you're supposed to use when it comes to AI and machine learning. But it turns out that it's just a multi-dimensional matrix of numbers. There's no voodoo, there's no magic there. It's just a big, long, big cuboid structure of numbers, or a hypercube in multiple dimensions. So for example, here's a whole load of little vectors. If anybody who's watching the weather reports around Hurricane Ophelia, you would have seen something like this showing you the wind speeds. This is two-dimensional, but you can imagine this in 3 dimensions, or 4 or 5. It's just a big matrix of numbers in multiple dimensions. It turns out that mathematical structure is a really good way to represent neural nets, because all the neural nets are is a whole load of neurons talking to each other, and each neuron has a particular weight, which is just a big, long structure of numbers. So you can represent neural nets using these multidimensional matrices. Okay, so that's the structures. How do you actually use them? Well, if you think about it, high quality results are when you take the user and the user's personal preferences and somehow put them together with the items in your search engine, and you end up with a rank, which is the order they come back in the search. So things that match a user's preferences and items that match the query should go higher up in the results. This is kind of what Google does. Well, it turns out that the way to work that out mathematically is you represent the user's preferences with a multidimensional matrix, and you represent the items in your system with another one. You combine them together using relatively simple mathematical operations, things like dot products, if you know matrix algebra, and you get a rank out of it. And if you want to think about it at a slightly higher level, all you're doing is taking users' preferences, mixing them together with the popularity of things in the database, and you're getting a rank back. So this is why Uber and Airbnb and most sites these days keep on insisting that you give 5-star rankings to things, because the number of stars that you give to any item gets put into these matrices, and they do this to try and give you recommendations, which works to a certain extent. Netflix, for all their scientific ability, doesn't really seem to be able to get this to work all that well. I don't know, especially not for me. But nonetheless, this is what's happening behind the scenes. This is why you're being asked for all these 5-star ratings. So if we go back to Vespa, there is really just one trick. It's only doing one thing. It's not a search engine. It's just really, really good at multidimensional matrix operations. That's it. That's all it does. It uses this mathematical operation, applies it to very large data sets, and you get good results as a result. So if I go back to those questions, those queries that I was trying to answer, I get good results when the search engine, Vespa, understands that I often organize seminars in the finance industry, and I need speakers that know about finance. And the system knows that because it stored that data about me. So it's not just this query, it's the fact that this is for the finance industry. And that's why it'll find the right sort of speakers. Or for people looking for conferences, if I know the data about what conferences I've been to, the system will know that I prefer small conferences as opposed to large ones, and will rank smaller conferences higher in the results for me. Or if I'm looking for AV people, well, again, I can use 5-star ratings from various different AV people in Brooklyn who have interacted with conference organizers over the previous year to pick out the ones that have high ratings, but are also in the location that I need. So by putting together the user's context and the qualities of the thing you're searching for, you get really good search results. This is essentially a recommendation engine, but it's one that applies to search and one that lets you get really, really good results, which is why I'm kind of excited about it, and which is why I think I'll be using this from now on rather than Elasticsearch, because it gives me what I need. To look at Vespa from an operational and a dev perspective, it's important to understand what's good and bad. So from a dev perspective, what's good is that this is a batteries included system. They have it's 17 years of development. They have a philosophy that they solve almost all your problems. So 95% of the time, there is a module or a plugin already in the system. You don't need to install it to do what you want. It has this really well-defined extension mechanism through Java applications. So adding to it or modifying the search results in the way that you need is really straightforward. And because it comes from the same teams that built Hadoop and things like that, integrating with other big data processing pipelines like Spark and Pig and Hadoop is really, really simple. They essentially are designed to work together. So that's really nice, because you can use Hadoop to build your neural nets, analyzing your data, which gives you a tensor, and then you get the tensor from the user's preferences, and putting them together makes it all work nicely. What's not so good on the development side is it's Java and XML, which is painful in this day and age, but worth it, I think, for this system. To really use it effectively, you will need to put a bit of time and effort into understanding the basics of machine learning. What I've given you here is just glossing over how the system works. You will need to put a bit of time and effort into understanding how the pieces fit together. You won't need to do a degree in machine learning, but certainly you will need to put a few days into understanding the basics of the maths. And it is a really big system. It has a huge API. So there's a significant learning commitment involved as well. It's not a system that you can just run in production, from reading a few documents for half a day. You will need to set aside time to understand it and read a lot of documentation. From the operations side, like I said, this is a microservices platform. So it gives you everything that you will expect. It scales dynamically, really, really simple. You add nodes and remove them quite easily, and it reconfigures itself. It's been packaged to run in Docker, so if you're deploying to Docker or Kubernetes, that's also really, really simple. And one of the cool things about it, the reason that I've decided to look at it, despite the fact that it's so new and has virtually no community yet, is that the documentation is excellent. So as part of the open sourcing process, whoever led that process must have insisted on really deep and full documentation, because literally everything is properly documented, which is awesome. On the flip side, there is no admin GUI. Nobody's built one. Obviously, internally in Yahoo, they have their own dashboards, which are separate from this. So you're interacting with it using curl and REST queries and that sort of stuff. I'm sure somebody will build admin GUIs over the next year, but right now there's nothing. It's all just console-based interactions. It's really resource hungry. So a production system, a minimum production system, is probably 3 separate machines with at least 8 gig each. It does a lot of in-memory processing, obviously, because it has to manipulate all these matrices. And you're not going to find answers to your questions on Stack Overflow at first. Right? There's, I think, 68 questions in total. So you're kind of on your own. You're reading the documentation. You're figuring stuff out. I'm sure that will change over time. But right now, the community is absolutely tiny. I'm going to do a tiny little demo just to give you a flavor for how this system fits together. Okay, so here's the search engine. It looks like another search engine, not one of the better search engines, obviously, but so instead of searching for conferences or speakers using all these drop downs, you're supposed to be able to do it in free text. So if I type in Dublin, for example, it'll give me back a bunch of conferences in Dublin. UXDX was one I spoke at recently, and you can see I'm down there as well. And you can see the nice thing is the search results are categorized for you, so it's searching over not just conferences, but also speakers or exhibitors or sponsors or venues or whatever you like, compared to other solutions which are just looking for events. Now, this data comes from a really, really simple spreadsheet that we put together. So we put together a couple of hundred entries and just fed them into Vespa. This means we built the search engine without putting together any analysis of the textual descriptions of the conferences or anything like that. It's literally just built directly from a spreadsheet, a really simple spreadsheet. And it already gives you high quality search results, which is quite impressive. And they will only improve when we go and spider all the actual websites and put in the text there as well. But just from this very, very small corpus and very, very small amount of text, we're still getting excellent results. As you can see on the GitHub, absolutely massive system. Like I said, batteries included. And if you look at the documentation, you can see there's masses and masses of documentation. So it's not a risky thing to adopt in that sense. It is a proven in production system. If you look at the implementation of that system that I've been using there, obviously my front end is a Fuge-based system running Node.js. Some of you may have seen that before. The Vespa system itself, I'm just running a single instance on my machine, but you just deploy that Vespa Docker image to all the different hosts that you're running on, as simple as, which is fantastic. And inside the Docker host, then you can see all of its own little, it has about 15 or so embedded microservices, and when you deploy applications, they go into this as well. But it's not like a traditional microservice system in the sense that everything runs on every machine. So the machines are undifferentiated. But you can see it is built on microservice principles. And like I said at the start, it's a good example of a Java microservice platform. And if that's what you're evaluating or thinking about using, this is, I think, a very credible alternative to things like Dropwizard. You don't have to build search applications. It's essentially just a web server hosting framework that happens to have all of this machine learning stuff available as well. Okay, so like I said, not a huge amount of resources. I've put up some links here to the documentation and the GitHub repo. There is also a really good discussion on Reddit and an AMA by the chief architect of Vespa. Really long, goes into a whole bunch of details about deployment trade-offs, all that sort of stuff. And there's one or two blogs as well. Obviously, I've decided this is what I'm going to use for my startup because it gives me the type of structured search results that I need. So I'm going to start blogging about it as well and let you know how I get on. And we'll see in 6 months, was it a crazy decision or not? Okay, thank you very much, guys. And are there any questions? Sorry. Go on.
So is it much different compared to the graph kind of databases like Neo4j? You kind of can, those you can put it. It's kind of similar to matrices, like you put in data and then they find the relative information. So is there any relations or differences?
The graph databases give you structured data in the same way that Vespa does. But Vespa adds the machine learning component, which means that you get, on those two metrics, you get higher precision. So the graph databases would suffer from that, the same problem that I spoke about, which is they would give you very high recall. You get all the relevant results, but you'd have low precision because you'd have lots of results that you didn't care about included in the data set. The essential difference with this is that it applies that matrix algebra to refine the data set so that it's good for you and the particular query that you are making at the moment. as opposed to just giving you loads of data. It isn't a graph database. So applications where you have to traverse a graph, like things in the travel industry and all that sort of stuff, Neo4j is still what you want to use. Oh, sorry.
Is the machine learning library a standalone thing? Is it a competitive like TensorFlow?
No. Okay. So it's important to understand what it is. It isn't TensorFlow. TensorFlow is a separate thing. Vespa processes the tensors. It doesn't generate them. So you have to use Hadoop and TensorFlow to generate the item tensor.
Okay.
So, but once you have that, you load it into Vespa, and then you get good search results as a result. But if you follow the tutorials, you can have an extremely basic understanding of how that works. And you literally just follow their instructions, and you get the machine learning data structures into Vespa, and you can use them. But that, like I said, you really have to put a bit of time into understanding how all that stuff fits together. But it does work very nicely with those existing tools. You don't have to learn new tools.
The question is, you mentioned two characteristics of Vespa, one being a search engine and another one a platform for microservices. When does it stop to being a search engine to be a good choice to manage our microservices?
I think to make it into a microservice platform, you would have to analyze the internal structure a little bit more, because you don't want to have the resource overhead of all the search modules. But from looking at the code base and how it fits together, it is a very component-based architecture. So you would just remove the search components. So the pieces that do the ranking, the pieces that do the linguistic stemming, all those pieces can be removed. And then what you're left with is the application container, the bit that does the distributed clustering, the bit that does the request proxying, the load distribution, all that sort of stuff, which is where you get a nice microservices platform from. It's a search engine in a box. It's not a microservice platform in a box. But it is something that you could credibly use to run microservices for sure. Okay, so to answer the first question, yes, you have to structure the data yourself. So Vespa expects a specific JSON format. So that Google Sheet that you saw, we process that into a JSON data structure. You can stream the data in, so you don't need to create like gigabyte level files. You can generate it over time and then stream it in. And I think that answers the second question. You can dynamically add new information to the system while it's running. And it updates its models as a result.
The update is instantaneous, or does it take any delay?
It's pretty much continuous, although there is a small delay because it auto shards internally. So it distributes load internally according to its own algorithms. And that takes a small amount of time to get across to the other nodes. But we're talking minutes here, like not hours to restructure itself. Yeah, so it's pretty cool that way, right? It adjusts dynamically. Okay, thank you very much, guys. Thank you.